All right, so this week will be the last week of classes. I'm only going to be posting two lessons this week. So we're going to start a new chapter, Trig. It's not a very long or challenging one, so I think two classes will be enough to cover what we need to cover, just to have the basics for grade 11, especially for 20-1. I'm not going to give you a test, but I will give you a quiz, which will be given to you on Google Form. I will release that on Thursday or something and hold office hours on Wednesday, if you have any questions. Okay, so um, let's start off with the starter question. So I'm asking you to find the missing side in this right angle triangle. Okay, so right angle triangle, that means it's a 90-degree. At the corner, right? Now, when we're talking about right angle triangle, there's a famous theorem that you can use to solve for the missing side, okay? And remember that theorem, which is known as the Pythagorean theorem, only works in a right angle triangle, okay? If you had some random triangle, let's say if this is what your triangle looked like, something like this. Now, this is not 90-degree anymore because it's more than 90, okay? So you cannot use the Pythagorean theorem, okay? Even though, let's say if you have the same measurements, okay? And I'm asking you to find this side, x, you can't use the Pythagorean theorem because this is not a right angle triangle, okay? So that's the key word, right angle triangle. And what we're going to be doing this year will also have to deal with the right angle triangles, okay? The techniques or that I'm going to be showing you are only applicable to right angle triangles, okay? So anyway, so how do you apply the theorem? Write down the theorem, write the formula if you want, right? It's just a squared plus b squared is equals to c squared, okay? Remember, you can only use this formula if you have a right angle triangle, okay? Now, I've already done this for you, but the second step basically is to identify what the hypotenuse is. Okay, the hypotenuse will always be opposite to this 90-degree angle, and your hypotenuse is always labeled C. Okay, A and B are irrelevant. I could call this A, I could call this B, which is what I've done, or vice versa. B, I could call this B, I could call this A. It doesn't really matter. What really matters is identifying C, okay? C is the most important piece, and C always has to be on the opposite side of your right angle. Okay, so once you have identified A, B, and C, which I've already done in this picture for you, it's just a question of replacing those values with what you see in the picture. So a is 15, so this is a squared, so I'm going to have to square 15, right? Plus, I don't know what b is, so I'm just going to leave it like that. So b squared remains b squared. C is 25, but it's c squared, so I'm going to have to square that, okay? So let me just quickly grab a calculator. So 15 squared is probably 225, and let me check. 15 squared, 225. Okay, so 225 plus b squared is equals to 25 squared is 625, okay? Now it's just a question um, of solving for b, okay? So just get rid of the 225, do the opposite, right? Minus 225, minus 225, 2, so this will disappear, and then you're going to have b squared is equals to 400, right? And you're not looking for b squared, you're looking for b, so you have to take the square root, you have to take the square root. So then b will just equals to 20, okay? Now, because the units are not given in the question, you don't have to put the units, okay? So it's just 20. And there you go, okay? So this is how you work with the Pythagorean theorem, okay? The famous formula, a squared plus b squared is equals to c squared. Remember that c is always the side that is opposite to your 90-degree angle, okay? So that's the key takeaway here. And it only works in a right angle triangle, okay? So now what happens, right? So my question to you is, what happens if you are only given one side, or if only one side is given to you in a right angle triangle? Okay, so in this case, I only know A, I don't know what B is, I don't know what C is. Can I use the Pythagorean theorem? So why don't we write down the formula, a squared plus b squared is equal to c squared. Okay, so using the formula, I know what A is. I don't know what B is. I don't know what C is. Okay, so I cannot use the formula because I have two unknowns. Okay, I'm putting X as in like or a cross that I don't know what those values are. Okay, so I have two unknowns. Can't really use this formula. Okay, again, Pythagorean theorem only works when two of the three sides are given to you. Okay, so in this example, for example, in this question, right, A and C are given to you. If two of the three sides are given to you, then you can find the third one using the theorem. Okay, so only one side should be missing. You can only have one unknown. Okay, for you to apply the formula. Okay, so right, so the answer is right. If only one side is given, then you cannot use the Pythagorean theorem. Right, this triangle can only be solved if two of the three sides are given to you, or which is what we're going to focus on this unit, is you actually don't need um, two sides. You can get away with only one side as long as an extra angle is given to you. What do I mean by extra angle? So remember, this only works in a right angle triangle, so we should know that one of the angles is 90 degrees, okay? But on top of that, we need an extra angle, either this one, okay, or that one, okay? It doesn't matter which one. If we're given, even if you only have one side, okay, so let's just pretend that this is the triangle, okay? So we know one of the sides. We know that this is 15. I don't know any other side. I don't know what B is. I don't know what C is, but I know that, let's say, this angle in green is 45 degrees, okay? I'm just making it up. Now, because I have a side and an angle that is not 90, I can actually find B, I can find C, I can find the other angle, I can do a lot of stuff, okay? If an extra angle is given, okay? Extra angle, right? So an angle that is not, so I already know that one of my angles is 90, right? So I know that this angle is 90. I just need another one, either the one in green or the one in purple, and then I can solve this triangle. I can find any side, and actually can find all the sides in this triangle and find all the other missing angles. Okay, which is the goal, which is what we're gonna work towards. So how do you go about doing that? Okay, you're gonna have to use some fancy mathematical, um, I guess, um, some fancy mathematical terms that you haven't I'm not too sure if you've encountered them before, right? Sine, cos, and tan. So they seem very technical at first, especially when you see it for the first time. But I'm gonna actually break this down to you and just to show you how this works. Okay, so essentially sine of an angle, cos of an angle, and tangent of an angle, there's just ratios. Okay, so what you see over here is a ratio. Okay, and how do you find the ratio? The key takeaway from this page is SOHCAHTOA. Okay, so this stuff over here is an abbreviation or an acronym or whatever you want to call it that will help you set up these ratios. Okay, so you just have to memorize SOHCAHTOA, and then this will help you set up the ratios down below. So how does it work? Let me show you. Okay, so in the the S stands for sine. Okay. Um, I guess before I start explaining the ratios, let me point out what the picture first of all looks like. Okay, so you have this right angle triangle. Okay, so how do you know it's a right angle triangle? It is given to you. Okay, so sometimes they might mention it in the question itself, like they've done in the starter question, like I've done in the starter question. Then you kind of have to manually insert this 90-degree angle. But in most cases, the 90-degree angle will be given to you, kind of like what you have in this picture, already given to you. Okay, now I said that for you to work out a question that only has one side given to you, you need an extra angle. So in this case, the extra angle is this one over here in purple. Okay, so this angle is given to you. Let's just pretend. Okay, so in this case, they're just calling it theta, but that's fine. So let's kind of understand how to I guess come up with what the hypotenuse is, what the opposite side is, and what the adjacent side is. Okay, so this is kind of important. So again, hypotenuse is the same as before. The side that's opposite to the 90-degree angle will always be called the hypotenuse. Okay, now the side that is opposite your the angle that is given to you is called the opposite side. Okay, so this is not too difficult. Okay, so you have your angle, the side that's opposite to this angle is called the opposite side. Okay, and the third side is what we call the adjacent side. Okay, so once you identify the hypotenuse, which is the easiest one to identify, right, because it's always opposite to the 90-degree angle, right, and then you identify your opposite side, which is opposite to the angle that's given to you. Your third side is the adjacent side. Okay, so that's how you identify the adjacent side. Now, using SOHCAHTOA, you can set up these ratios that you see down below. Okay, so let's start with SO. Okay, so the S in the SO stands for sine. Okay, and once you put sine always has to once you use sine, after sine you always have to put an angle. Okay, so it always has to be sine of an angle. Okay, so make sure when you use sine, put angle after that. Okay, sometimes the angle might be called theta, sometimes it might be angle A, sometimes angle B. Okay, depends on the question. Okay, so the S over here stands for sine theta. Now the O stands for your opposite side. Okay, so this is your opposite side, and the H is your hypotenuse. Okay, and this will always be like the first letter here after S will always be in your numerator, and the second letter H will always be part of your denominator. Okay, so this what this tells you is that sine of the angle is equals to the opposite side divided by the hypotenuse. Okay, and in the similar fashion, you can work with ka, right? So the C again stands for cos of your angle. Okay, the A is your numerator, so that's your adjacent side. And then you have to divide this by your hypotenuse, okay, because H stands for hypotenuse, okay? And then finally, let's work with TOA, okay? So as you can see, SOHCAHTOA helps you set up these ratios, right? The T over here stands for tan of your angle. The O is your opposite side, and the A is your adjacent side. And again, opposite side will be your numerator, adjacent side will be your denominator. Okay, so you don't need to memorize this formula, right? You just need to know SOHCAHTOA. This is what I'm going to ask you to memorize. And then you can easily set up the ratios down below using that um, abbreviation, okay? So it's just a trick that works, okay? So now let's apply this. Okay, so let's do a practice question. So in the triangle DEF, right? So this is just a symbol, right? You have a triangle, and these are kind of like your vertexes, okay, or vertices. I think I don't know what they're called. I think it's vertex is one, and the plural of that is vertices. Okay. Anyway, so your triangle DEF, okay, uh is given to you, and then what are they asking you to do? They're asking you to identify the side opposite to angle D. So let's put angle D here in purple. Okay, the side opposite to angle D is this one, right? So this side, so why don't I write this down underneath? So the side opposite to angle D is the side EF. And then when you're talking about a side in a triangle or any shape for that matter, you just have to put a bar on top of it. Okay, this just means side EF. Now you can write this out in English, side EF, but that's long. The mathematical notation would be this. And the adjacent side, I'm just going to put ADJ for adjacent to angle D. Now this one might be a little challenging because your angle D is this one over here. Now you might be thinking which side is adjacent. So let me use a different color for adjacent side. Is it and it's a fair question to ask, right? Is it this side or is it this one, right? It's one or the other. Um, but remember, because this is a 90-degree, right? Then the side opposite to that has to be your hypotenuse, right? And we already know that this is the opposite side. So this has to be your adjacent side. Okay, so your adjacent side will be side D E. Okay. So DE is adjacent, EF is opposite to this angle, okay? So remember, first you have to pick your angle. Because if you pick a different angle, let's say you pick this angle in green over here, then your opposite sign for the angle in green would be this one, right? Because this is the side that's opposite to it. Hypotenuse will still stay the same, and this would be your adjacent side. Okay, so it really depends on from which angle you're looking at. Okay, so and again, I'm gonna do a few examples, and then hopefully this will make more sense. But let's just focus on the question for now. We're talking about this angle, so let's view everything from this angle's perspective, okay? And then the second question is, so this was question A. Let me write this a little nicer. Question A. And question B is, determine sine of D and cos of D. Okay, so sine of this angle and cos of this angle. So to answer a question like this, you have to use SOHCAHTOA. Okay, so because they're only asking me to find sine and cos, right? TOA is for tan. I don't really need it, but I'm still gonna write it. This is not, I don't really need that, okay? I'm only gonna be focusing on SO. Okay, so means sine of my angle, right? The S over here stands for sine of my angle, is equals to my opposite side divided by, right, the opposite side, which is 5, divided by the hypotenuse, which is 13. Okay, so 5 divided by 13. But they're asking you to, express this to the nearest hundredth. So you'll have to, unfortunately, divide out this fraction and give an approximation of this ratio. So I'm just going to put this approximation symbol because it's not going to be an exact number. 15 divided by 13 is actually 5. Sorry, 5 divided by 13. 5 divided by 13 is approximately 0.38, okay, to the nearest hundred. Okay, so 2 decimal places. And then finally, ka, right? So cos of my angle is equals to the adjacent side divided by my hypotenuse, right? So the adjacent side to the angle in purple, right? This angle, the adjacent side, I've already labeled that in the picture, is actually 12. And then your hypotenuse is still 13. Okay, so just do 12 divide by 13. And again, I should probably use the approximation symbol. So this is approximately 0.92. Okay, so this just gives you a ratio that again is very useful to solve for the unknown side, which is what we're going to do in the next example. Okay, so just understand how SOHCAHTOA works, right? This is the key takeaway. Understand how to set up your ratios. Understand that this only works in the right angle triangle. Okay, no, it does not work in any other triangle, only in right angle triangle, just like the Pythagorean theorem. And understand that you have to view things from the perspective of the angle that's given to you. Okay, so in this case, it's the angle here in purple. I'm looking at everything from this angle's perspective. Okay, so from this angle's perspective, this is my opposite side. Hypotenuse is always going to be the same. It's always going to be opposite to the right angle. And this is your adjacent side. Okay, I hope this is kind of making sense. Now let's move on to a more difficult question. So determine the length um, of each indicated side to the nearest tenth of a centimeter. Okay, so we see there's an x placed over here, so they're asking you to find this length. Okay, so excuse me, so this angle is given to you. This is 50 degrees. So as you can see, right, so why don't we just erase everything. If this is a right angle triangle because it's a 90-degree, unfortunately, I cannot use the Pythagorean theorem because this side is missing, that side is also missing. So two of my sides are missing. Can't really use the Pythagorean theorem, but I can use SOHCAHTOA because I know one of the angles. Okay, it's 50. So one side is given to me, and I have an extra angle besides this 90. Okay, so I know that this angle is 50. So I can use SOHCAHTOA. Okay, but the question becomes, what should I use? So the first step is to write SOHCAHTOA. So SOHCAHTOA. TOA, okay? And now just look at the picture, okay? So we're looking at the, this, why don't I just stick with purple, this angle here in purple, okay? Now, what is given to me? What do I know? So the side opposite to my 90 degrees is my hypotenuse. So the hypotenuse is given to me. I'm going to put a check mark underneath H because I know that, my hypotenuse is given. So that means I'll either have to use the sine ratio or the cosine ratio, because if I use the tangent ratio, I don't have the opposite side. I don't have the adjacent side. It's not going to work. I'm going to have two unknowns. Okay, so I'm not going to use the tangent ratio. I'm going to have to use this one or that one. So let's see, which one should I use? So because I'm looking for x, which is opposite to my 50 degrees, so this is my opposite side, right? Because when you're, right, this is your angle, the side opposite to that angle is called the opposite side. Now, since I'm interested in the opposite side, I'm going to have to use sine, okay? Because if I could use cos would work, but instead of finding the opposite side, I'm going to end up finding the adjacent side, okay? Which is not what the question is asking. But you could find the adjacent side. Then you're going to have two sides given to you, and then you can use the Pythagorean theorem to find x. Or you could, just do what I am about to do, work with the sine ratio. Okay, so remember sine of your angle. So S stands for sine. Sine over angle is equals to the opposite side, so which is x. So let's just put opposite, right? Opposite divide by hypotenuse. Again, you don't have to put the capital letters, but if you really want to, you could. Now, do I know what my angle is? Is it given to me? Yes, it is, right? So maybe not quite visible, but you can see it's given to you. It's 50. So sine of 50 is equals to the opposite side, which is x, I don't know what that is, and my hypotenuse, which is 4. Now here, I'm going to ask you to be very careful. I'm going to ask you to check whether or not your calculator is in degree mode. Okay, so one way to do that is to take sine of 90. Okay, so just take sine of 90 in your calculator and press enter. If you're getting 1, then you're in degree mode. You're good. Okay, if you're not getting 1, then you're not in degree mode. Okay, so why don't I show this to you? So my calculator, I think, is in degree mode. So the mode button is right in between the second or the shift button, right? And the delete button. Okay, so right in between this one over here. My calculator is in radian. Okay, so good. So now let me take sine of 90. You'll see that I'm not going to get 1. Okay, so if I take sine of 90, close the bracket, enter, I'm getting 0.89, which is not 1. Okay, so that's an indication that I'm not in degree mode. So I'm going to go back to mode and then click on the down arrow, and then the right one, and then click enter so that it goes to degree mode. Okay, and then clear this. Now if I take sine of 90, I'm going to get 1, okay? So there are two different modes, and you will understand when to use which mode in actually in grade 12. But for now, just stick with degree mode, okay? So this is a way to check if you're in degree mode or not, okay? Another way to check is just to simply use your calculator and see which mode you are in. Now, if you bought the calculator that the school requested you to buy, then this is what it will look like. If you have a different model, it's the same process. Okay, just find the mode button. Okay, click on it and then make sure you're in degree mode. And to verify that you're in degree mode, just take sine of 90 and check if you are getting a 1. Okay, this would be in degree mode if this is what you're getting. Okay. Anyway, so now that that's done, why don't we solve for x? So to solve for x, you just need to get rid of the 4. So just multiply by 4 on both sides, right? So x will just equals to 4 times sine of 50. So why don't we do that, okay? Let me go back to my calculator. And I think I changed my mode to degree mode, but I will just check again. Yeah, okay, so 4 times sine of 50, and then enter. So 3.06. Okay, so roughly my answer is approximately, okay, so I'm just going to use the approximation symbol, 3.06 point. And make sure your units are matching, okay? Because the hypotenuse was given in centimeters, this has to be in centimeters, okay? So my writing doesn't look really nice. I'm gonna just erase this, write it again. So 3.06 centimeters. There you go, okay? So again, everything boils down to understanding that SOHCAHTOA only works in a right angle triangle. So verify if your triangle is right angle. Then based on the situation, right? See what is given to you. In my case, the hypotenuse was given. So I put a check mark under the H, which indicates that I either have to use the sine ratio or the cos, because if I use the tan ratio, I'm gonna have two unknowns. It's not gonna work. And because I was interested in the opposite side, I had to use the sine ratio. Okay, it forced me to use the sine ratio. I could have used the cos, but then I would have obtained this side over here, which is the adjacent side, which is not what the question was asking for. Okay, so just be careful with that. Now let's do one more question, and then I will stop over here and assign you homework. So this one I'm going to go slightly faster because I think I spent a lot of time on that question. Determine the length of AB to the nearest tenth of the centimeter. Okay, so they're asking me to find the length of this. I'm just gonna put X over here. This is what I'm interested in. Okay, so this angle is given to me. So that means, the side that is opposite to this angle is called the opposite side. So basically, I'm interested in finding the opposite side. Okay, so I would and then hold on. So let's just label everything. So this is a 90-degree triangle, right? So the angle, the side opposite to this angle will be your hypotenuse, and this is your adjacent side. Okay, so now that you have your O, A, and H, let's write down hold on. SOHCAHTOA. Okay, so because I am interested in the um again, there's many ways of doing it. Okay, so I know that my adjacent side is given to me. So my adjacent side is given to me, my adjacent side is given to me. So that means I will not be using I'll either have to use um, ka or toa, right? So either the cosine ratio or the tangent ratio. But what am I interested in? I'm interested in the opposite side. I'm interested in this side. So I'm going to have to use the tangent ratio. Okay, so just using TOA, I know that tan of my angle, right, is equals to the opposite side divided by the adjacent side. Okay, so this is the ratio that I'm going to be using. Okay, and the picture will tell you. Once you identify O, A, and H, you will know what ratio to use. Okay, again, because the adjacent side is given to you, um, the adjacent side is only used in the cos and tangent ratio, not the sine. So I know that I cannot use sine because sine will have two unknowns, right? And then because you're interested in the opposite side, you're gonna have to use the tangent ratio. Okay, so the angle is given to you, right? So tan of 30 is equals to the opposite side, which I don't know, so I can just put an x over here, and my adjacent side is actually 10. And then it's just a question of solving for x, right? So just multiply by 10 on both sides. So this will disappear. And then x will equals to 10 times tan of 30, which will approximately be 10 times tan of 30, which is approximately 5.77. Again, your units have to match. So because that was given to you in centimeter, this has to be in centimeter. Okay, so the focus of next class is to expand on this. So let me just tell you what I will do next class. So now that you know that this is 5.77 centimeter, now you can actually use the Pythagorean theorem to figure this side out, or you could just use the uh, cos ratio to find your hypotenuse. Okay, there's many ways of finding the hypotenuse, either using the Pythagorean theorem now that you know what this side is, or by simply using the cos ratio, which will help you find the hypotenuse. So next class, what we'll do is we won't just be solving for one side, we will solve for every side in this triangle, which is what your quiz will look like. Okay, and I'm going to ask you to find all the angles inside your triangle as well, which isn't too difficult. Okay, so So that is it for this class. Okay, for homework, I'm attaching a PDF worksheet. I'm going to ask you to do question 9 and 16 on this worksheet. And the questions 1, 2, and 3, that will be assigned to you in my next lesson. So for this lesson, just do question 9 to 16. Again, you don't have to do all the questions. Just maybe pick a couple if you really understood what I did in this video, just to check if you understood everything. Because when someone else is doing it, it's not that difficult. But when you do it for yourself, that's when you struggle a little bit, right? So do a few questions. If you need more practice, do all of them. Okay. I'm gonna be posting one more video, and then that would be it for this year. Okay. So we're almost there, guys. Just hang in. We're almost done. Okay. So thank you so much for watching my video. You guys have a nice day.